Hey everybody, Dr. Phil here. This is going to be a video on collecting, preparing, and examining data from the standpoint of, research projects and research design. So let's start by talking about a data collection timeline. So the dates and times for training of data collectors, if applicable, that, don't negate that because that can take a lot of time to train people how to collect data. There might be a certain places you need them to go, certain way that you need them to collect that data. The activation dates and times, the start and stop times of each data collection task. So, if it's, because again, this has got to be uniform. So you want to make sure that everything is being done, you know, to one respondent, one participant in the same manner as somebody else. When data entry starts and is expected to finish, to include both automated and manual entry. So most of it will probably be automated, but there might be occasions and times where, incidences where the data collector may have to manually enter data. And that's okay. When data editing starts and is expected to finish, and when the clean data file will be ready for processing. So collecting the data. So again, train the data collectors, determine the timeline, implement the research task and processes, invite the chosen participants, activate the research tasks, remind participants to complete them, and then ultimately enter the data. So pretty logical, pretty straightforward. With regard to instrument disposition, so you might want to mail it, you may want to fax it. It may be uploaded. It could be put into a Dropbox. It could be in an email. I'd say these days the most common one is if it's any of these, it's probably like an upload. You get like a survey link to like Qualtrics is a good example of that. You just go to the Qualtrics website. You fill it out and then you just submit it. It's done. It's all web based. You don't have to download anything to your computer. You don't have to have any special software or anything like that, which makes it very handy. So this is an example of a coding scheme. So we have the variable IDs, which again wouldn't mean anything to anybody but the researcher. We've got the location, we've got the variable label. So if we look at say row 4, 1, 2, 3, 4, well let's look at rows 3 and 4. C1 is gender, and then C2 is marital status. C3 is housing ownership, C4 is birth year, C5 is 5-digit zip code, etc. And then you can see we have the response codes. So if we were coding for marital status, C2, variable C2, then 1 is married, 2 is widowed, 3 is divorced, so on and so forth. And then we've also got like our nominal and ordinal measurements. Um, there's really two tasks for preparing the data: the post-collection coding of the data, and then if we need to, we may have to also edit the data. So editing criteria, we want to make sure that the data that we've gotten is accurate. We want to make sure that it's complete, and we want to make sure that it is appropriately coded. So if any one of those three things is out, then it's going to cause problems when we run the analysis. Or maybe it causes a problem, but we don't know it's caused a problem. It just means that the analysis is faulty, even if perhaps we don't realize that. So field editing, this is where we identify any entry gaps. If there's any ad hoc notes, they get translated. And this is kind of at the point where the data is being validated. Is where we're looking at the data and we're saying, this is good. Okay, well, this is a problem. Somebody answered this wrong. They didn't, the zip code's only 4 instead of 5, so on and so forth. Pre-coding is usually done, certainly even all automatic surveys. So, are you currently like number one, employed for wages? So if you selected employed for wages and the system's already coding it to number one, that's good because that takes a step out of it, post all of the data being gathered. Appropriately coded for analyses. So the categories should be exhaustive. They should be appropriate to the research problem, obviously. So if you're asking like, marital status, then, married, single, divorced, widowed, etc. Mutually exclusive. So for example, you can't be married and divorced. So the system would be coded to where if you select this one, it doesn't allow you to select any others. And then derived from one classification principle, as I just alluded to. So data entry, it may require keyboarding, you can use database programs, possibly optical recognition, voice recognition, and digital barcodes. Now, a lot of the data entry, if you do this right, there's programs where the data will be, it'll be, yeah, you can look at it, you can clean it, you can check it to make sure it's good, no missing numbers, etc., missing values, and then it will actually put it into the statistical program for you in order for you to conduct the analysis. So missing data types, really kind of three ones here. So we have what we call MCAR, data missing completely at random. And then we have data missing at random. And then we have data missing but not missing at random. So the bottom one would be, somebody just said, I'm just not filling this out. And then, just opted to not do that. And perhaps our system wasn't coded when it was having them fill it out. Maybe it wasn't coded to insist on, to prompt that to be completed before continuation. With respect to correction techniques, there's what we're sort of getting at here. What we're getting at here is what happens if you're looking at your data and you're like, oh, we've got like missing values. What do you do? And there's different ways. You can listwise deletion just basically says let's just could we just remove that variable completely? I will tell you from experience that if I've looked at a variable and there's been a lot of missing values to that variable, I may have said I'm not really comfortable just substituting in maybe like the mean value for those because there's just so many missing ones, which obviously affects the accuracy of the mean I'm substituting. So what I might do is just, even if I, hate to do it, don't want to do it, I might just take that variable out completely. Um, and then predictive replacement, you heard me just talking about maybe we just substitute a value for the mean. That's something that I would consider doing as a researcher. Let's say like I had 100 values for a variable and I had, say, three or four missing values. Then I might say, okay, then yeah, I'm okay with substituting those values, those missing values for the mean. If there's a quick, easy, and cheap way I can get those values, then maybe I'll try to get them. But if not, and most times it's not, then I'll probably just substitute for the mean, or if I need to, I'll just remove the variable completely. So data analysis techniques. So we have really exploratory and we have confirmatory. So think of like exploratory as we don't really know. There's actually two statistical techniques that I won't get into in this video. Maybe I'll do it in a different video, but it speaks to these two, what we call EFA, exploratory factor analysis, and CFA, which is confirmatory factor analysis. The idea of exploratory is we really don't know, in some cases, what we're sort of looking for. We're just kind of exploring. Um, and then confirmatory is, okay, we kind of have an idea of what this is, and we would just like to confirm it. So again, think of exploratory as there's probably nothing that's yet been assumed, and then confirmatory is, okay, yeah, we kind of know what this is, and we would just like to, or maybe I shouldn't say no, but maybe we do know, maybe we have a good idea, and we would just like to be able to confirm that. All right, quick and short video for you. Thanks for watching, and I will see you all soon.